Here is all my working answers in case you just need to see that. I think this could be a real strength of ours. Everything in this problem we are strong at and we could handle, and we know how to do it all the way down to the last part with the partial fractions there. So first part, I mean, they give us this function in the derivative with these k in there, but then it gives us k is equal to 3, which means I could plug a 3 in for those k's, and I have my function, I have my derivative right away. So there's our original function, and it says write the equation of the tangent line. So we're going to need a point and a slope. Now to get the point, I got to take this x equals 4, plug that into the original function to get the y value. So my x was 4, I plugged the 4 into that original function, got 1/4 for the y value. So there's my point. And then for the slope, we got to plug it into the derivative. So here's my derivative. I got to take a 3, plug it in for the k's, and I'm going to take a 4, plug it in there for the x's. That gave me that. Did some arithmetic. There's my slope. Do the point slope form, got the equation of the tangent line. Now for part B, it tells us k is 4, so we got this function now. And then we want to know, is there a relative maximum or neither at the x equals 2? Now this first part, I thought I needed. I plugged in k equals 4 and x equals 2 to that derivative. I did get 0, so it means there's a possible relative maximum, but we got to check and see if it switches sign. So I guess in hindsight, I don't really need to do that first part right there. I could just, all I did was take k equals 4, plug it into that for k, and then there's our first derivative here. And we're going to figure out max or mins. We're going to like set the top and bottoms equal to 0, right? So if I set the top and bottom equal to 0, we're going to get 2. We're going to get like 0 and 4 for like the critical numbers. And then so all I'm doing, all it asks for is around x equals 2. So I just got to check that first derivative to the left and to the right of x equals 2. So I went back to what we did a long time ago. I just make like an x, y, y prime chart, or just the x, y prime chart. That's all I need. And I'm checking numbers to the left and to the right of that 2 right there. And I guess it was kind of helpful to know this, so I can't plug in 0, I can't plug in 4 because that derivative is undefined right there. But if you just plug in 1 and 3 to that derivative, that bottom part is always squared, which means it's always positive. So you really just got to plug it into that numerator. So when I go plug in 1, I get a positive number. When I plug in 3, I get a negative number. And then the chart itself is not your justification. The chart might help you figure out your answer. It might help you organize some things. But when you justify your answer here, which is what it asks us to do, they always say the charts are not your justification right there. You got to tell me the obvious, why it is a max versus a min. And so we know from before that means our function goes up and then it goes down. So that's going to be a relative max. So you have to say this statement, f has a relative max at x equals 2, since the f prime changes from positive to negative. They need to hear this. The chart is not necessary. If you can do that without the chart, fine, but you have to have this down for that proper justification. All right, now also what you could have done on this one is you could have done the second derivative test. Knowing that our first derivative is equal to 0, I could then take the second derivative of this. That would involve the quotient rule, and then that second derivative at x equals 2 would have been negative, which tells us the graph is concave down. So remember, if your first derivative is 0, that means your graph levels off, and your second derivative is negative, that means your graph is concave down, so that forces that to also be a maximum right there. But I just thought this was quicker and easier. I didn't want to have to mess around with the quotient rule and the second derivative of that thing. Letter C says critical point. What we know a critical point is that's a point where the derivative is equal to 0. That's it. Now max and min, the derivative has to change sign, but a critical point is where the derivative is equal to 0. And so it gives us x equals -5. So all I'm going to do is take a -5, plug it into that first derivative for the x's, and that gives me an equation with the k's, and I set that equal to 0. And then we know a fraction is equal to 0 where the top is equal to 0, and then that's why I'm just setting that top part equal to 0. Don't letter C. Letter D, I think we've done a lot harder partial fraction problems. There's 2 parts of this though. One, it just says find the partial fraction decomposition, which means just find your A and your B, plug them back in, right? So remember, you factor it. You could factor at the denominator. We're going to do partial fractions. Those are 2 linear factors. You can put a over x, b over x minus 6. Choose easy values for x that make these things equal to 0. Like if I choose x equals 0, the b goes away. If I plug in 0 for that x, I get -6a. There are no x's over here. If I would plug in 0 for those x's as well, but I get a is -1/6, and then we can plug in x equals 6. That a goes away, and I get 6b is equal to that 1. But like if there were any x's over there, you would also plug in the 6 for those x's as well. You get your b is 1/6, and then when you plug those back in, that's all they want for that first part. Just find the partial fraction. So you find your a and your b, you plug those back in, and then that's your partial fraction decomposition right there. And they accepted like, you know, either one is okay. If you could one drop the x's down, you can. But then the last part of that, we just need to do an easy integral of that f of x. And this is what we've been practicing with our partial fractions. So pull out the constants, easy integral there, easy integral there. And just be careful if there's any balancing. Like if I got a 1 over, like if I have a 1 over 7x minus 6, then I need to balance that 7 with the 1 over 7x. So just be careful with those. And I like that problem. If we practice that, we should be perfect with all those things in there. That's a lot of our strengths right there. Olives.